Hello everyone, welcome to Chemistry Stars. Here we have part 2 video of polymer chapter, and the topic which we are discussing here is the continuation of the previous video, that is classification of polymers. So before going into the topic, let me tell you one thing, that you should take a long sheet of paper or a notebook, and you have to draw a table containing 3 columns. In the first column, put the heading as monomer, second column heading is polymer, and then the third column uses. From here onwards, we are going to familiarize some polymerization reaction and polymers. So if you are going to study the first polymer, for example, let us say polyethylene. Put number 1 here, write its monomer, that is ethene, here polyethylene, and I'll tell the uses, so you have to note down the uses in this column. If possible, please don't forget to mention the polymerization reaction in this area. Okay. And if you are going to study the next kind of polymer, put the number 2, write its monomer, write the name of polymer, write its uses, and mention the polymerization reaction of it here. Like this, you have to write all such things related to every polymers which you are studying from this chapter. You can call it as micro notes or cheat sheet. So this will be very helpful a few days before the exam, or a day before the exam, to memorize everything quickly, and this is the right method to study this polymer chapter. So please try to follow this method. Okay, fine. So let us deal with the topic classification of polymers. I have done the first and second type of classification. Now we are going to study the third type of classification of polymers, and third type is on the basis of mode of polymerization. Mode of polymerization. I have already told you what is polymerization, right? Polymerization is the when small monomers combine together to form a large macromolecule known as polymer, then that is known as polymerization. Fine. Okay. Now on the basis of mode of polymerization, we can classify mode of polymerization. Polymers are classified as two types. First type is addition polymerization. Fine. And the second category is condensation polymerization. I will tell this condensation polymerization later on. Now we are only dealing with the addition polymerization. So addition polymerization means monomers having double or triple bonds repeatedly add together to form polymer. Fine. And that polymerization process is known as addition polymerization. So here in addition polymerization, addition polymerization takes place in monomers having double or triple bond. Remember this point. Okay. Addition polymerization will only take place in monomers having double or triple bond. If I talk about the examples of addition polymerization, formation of polyethylene, polypropylene, all these are examples of addition polymerization, and these are given in your NCERT textbook. Fine. Okay. So let me write ethene. CH2 double bond CH2. This is ethene. I think this structure you have already studied in organic chemistry, right? I am taking ethene. I am taking n number of ethene. Fine. In order to do polymerization. So n molecules of ethene undergo addition polymerization to form polyethylene. And how we represent this polyethylene? Here we have double bond, right? Remove this double bond, and I am putting a single bond here. And after that, I am putting a bond here. I am putting another bond here. Close it with square brackets and put this n here. Okay, and this is known as polyethylene. Fine. Okay. Now let me talk about polypropylene, that polymer. I'll tell the uses later on. Okay. Polypropene means n number of propene molecules combined together. Fine. Propene is the monomer. So if I write propene, I can write it as CH3 CH double. Okay, CH double bond CH2. Right. This is polypropene. But I only need this double bond. Okay. So I can write the CH3 downwards. Fine. I want to see this double bond. Fine. So I am taking n number of propene. I have taken n number of propene and this undergo addition polymerization reaction. So remove the double bond between these two carbons. So I can write CH single bond CH2. Fine. And there is a CH3 here. So I am putting that CH3. Put a bond here, close it with square brackets and put the N here. Here we have polypropene. This is how polypropene is formed. And addition, remember one thing, that addition polymer is again of two types. Fine. One is known as homopolymers. Addition polymerization il rendu polymers form cheyan pattum. Onnana homopolymers and the other one is heteropolymer, or you can call it as copolymer. Okay. What is the meaning of homopolymer? Homopolymer means same monomers are combined cheyyunnadengil, that is homopolymer. Okay. In case of ethene and here in case of polyethene, only n number of ethene molecules are combining, right? Ethene. These all add together to form polyethene. So only one kind of monomer is there. In case of polypropene also, the only monomer we have is propene. Fine. So these that is polymers formed by the combination of only one kind of monomers is known as homopolymers. So here polyethene and polypropene are examples of homopolymer. Now let us look what are copolymer. And first of all you have to note this down and we can check the details about copolymer. Okay. So we have already seen that examples of homopolymers are polyethene and polypropene. Now we are going to study about copolymer. Fine. So copolymer means the copolymer is a polymer that is formed from two different monomers. Okay, now the examples of copolymer are Buna N, we can say Buna S, Buna N. These all are synthetic rubbers, right? So Buna S, Buna N, all these are copolymer, or you can call it as heteropolymers also. But in the NCERT they have mentioned as copolymer. Fine. And in the NCERT they have already given you the polymerization reaction of Buna S. So I am telling that now. Buna means buta 1,3-diene and S stands for styrene. I think this is how this name Buna S is originated. Buna means buta 1,3-diene molecule and S stands for styrene. Now let us look how this polymerization reaction takes place. So one monomer is buta 1,3-diene. So I can write the structure of buta 1,3-diene as buta means 4 carbon, right? 4 carbon atoms. 1,3-diene. One in first and third position we have double bond. Diene means double bond. So in the first and third position, that is first position here 1, 2, 3. Here also we have double bond. Now I can fill the hydrogens. Okay. This is buta 1,3-diene monomer plus styrene monomer. I can write styrene as this is a benzene ring. In this benzene ring put CH double bond CH2. This is styrene. Okay, CH2 double bond CH and here benzene ring. Style that is styrene. Fine. Okay. Now in the NCERT they have written as, they have not shown this ring. They have written as C6H5. Now I want to take n number of monomers, right? Here also n buta 1,3-diene and n number of styrene. These two different monomers undergo polymerization reaction, and I can write the polymer as here. Please remove this double bond. Fine. CH2 single bond. CH, that double bond will come here because E carbonum and E carbonum valency should be satisfied. Fine. So this double bond will come here. Here the double bond remove aki, but double bond forms. This is the carbon 4 valency satisfied. In CH, double bond under put single bond. Remove that double bond and I have put the single bond. CH2. And you have to combine these two monomers, then only it will become polymer, right? So I have to combine these two monomers. Here we have C6H5. One second. C6H5 continuously. Let me put this C6H5 downwards or upwards. Okay. Like this we have done in the propene molecules also, right? Because only we want this carbon, which is sp2, that is carbon attached to this double bond. Okay. So I am putting the C6H5 group in the upside. Okay. And we have CH. Remove this double bond. Here we have C6H5 and CH2. Fine. Put a bond here, close it with square brackets, write N here. And this is known as Buna S. And this is Buna S polymer, which is a synthetic rubber. And this is a copolymer. Why I am calling it as copolymer, or you can say it as heteropolymer, because this Buna S is formed from two different monomers, that is buta-1,3-diene and styrene. Fine. Write it down. Now let us look the second type second type which is there on the basis of mode of polymerization, that is condensation polymers, or you can call it as condensation polymerization. And that condensation polymerization means it is a reaction in which repeated condensation occurs between two different monomers. Okay, buddy. Two different monomers തമ്മിലാണ് condensation reaction നടക്കുക. And condensation means it results in the elimination of small molecules, like condensation എന്ന് പറയുന്നത് condense ചെയ്ത് പോകും. എങ്ങനെ ചില ചെറിയ ചെറിയ molecules like HCl, R means hydrogen chloride, ROH, water molecule, ഇങ്ങനെയുള്ളതൊക്കെ eliminated ആയിട്ട് പോകും. Okay, that is condensation reaction. And okay, by repeated condensation reaction, polymers are between two monomers having bifunctional or trifunctional groups. Okay, here remember that condensation polymerization reaction takes place between monomers having bifunctional or trifunctional groups. I will tell what are these bifunctional or trifunctional group. Examples which are given in the NCERT are nylon 6,6, nylon 6 terylene or dacron. But the polymerization reaction of nylon 6,6 is only shown in the textbook. So let me show you. This is the polymer, okay, nylon 6,6, which is a condensation polymer. And here 6, this all stands for number of carbon atoms. Okay, 6 implies the number of carbon atoms. So if I talk about nylon 6,6, this 6 it represents hexamethylene diamine. Fine, that is the monomer. Hexamethylene diamine. Methylene group means CH2 group. Okay, hexamethylene means we have 6 CH2 group. Fine. Now, okay. Hexamethylene diamine means 2 amine groups. That is, here also we have NH2. Here also amine group, that is NH2, NH2. This is hexamethylene diamine, and we are taking n number of hexamethylene diamine. So this 6, that stands for 6 carbon atoms present in this monomer. And this another second one, okay, this 6 stands for adipic acid, and adipic acid I can write it as, okay, adum 6 carbon ulloru monomer aanu. adipic acid. Fine. So here also I have CH2 4 times. Fine. And a COH group. Acid another acidic group. So here also COH. Here also COOH. I am taking n number of adipic acid. There are 6 carbon atoms. Fine. So these are how you write the monomers. Okay. Now I have told you this condensation polymerization takes place between two different monomers having bifunctional or trifunctional group. Here, one monomer there are two functional groups, right? NH2, NH2. In other monomer also there is another functional group, that is COH. Fine. So here COH combines with NH2 group. The monomer containing COH group combines with another monomer having NH2 as the functional group. So we can say that here monomers having bifunctional or trifunctional groups. Okay, now let me write the polymerization reaction. The product formed is, what you have to do is, from all the NH2 you have to remove a hydrogen, and from each from the COH you have to remove this OH, and from each NH2 you have to remove a hydrogen. Okay, appo ividana OH um H2, okay, OH um H2 um thamil remove OH and H, right? So n number of water molecules will be eliminated. So that is why we are calling it as condensation. Ivida water aanu eliminate cheyidu povuka. Okay, so I can write ivida njan oru H kalanju. So NH, put a bond here and square bracket. CH2 6 times NH. But then the OH has gone. Then after that we have C double bond O, CH2 4 times, and from here also you have to remove the acid, and then you have to remove OH. C double bond O. Put a bond here. Put the close it to the square bracket and put N here. And this is nylon 6,6. That's it. We got the polymer. Fine. This is condensation polymer.